Hi everyone, my name is Daniel Vivas. I'm the General Product Manager at SkyCiv Engineering. In this video, I'm going to show you 4 common modeling techniques using rigid links. Remember, you can find more information in our documentation. So let's get started with this example. The first example that I'm going to show you is how to apply a load at a center of gravity. Remember that these rigid members are often used to transfer forces from one location to another. You can see these elements as infinitely rigid members. Okay, let's use the pen tool to create a basic structure. I'm gonna load a section from the section builder. In this case, I'm going to use the database. Let's select an American section, AISC, W shapes, and I'm going to select the first one. Let's click on submit. And now you can see that all of our members are using this section. So if we check the 3D renderer, you can see the result. Let's imagine now that we need to apply a load in the center of gravity of this cube. I'm going to show you how to do it manually. So in this case, we need to define a node in the center of gravity of this cube. Let's click on apply. We have our node created, and let's create our rigid links. So in this case, I'm going to use the pen tool again. If we select one of these new members that we have created, you will see that we have continuous members. So let's check the 3D renderer. And as you already know, we want them to be rigid links. So the way how we can achieve that is by selecting all of these new members, hitting Control, selecting the members. Let's click on members. Let's change the type from continuous to rigid link. And let's click on apply. You can see that now we have this R letter on top of the members, and let's check now the 3D renderer to see our result. Let's define some supports for our structure. The first thing I'm going to do is select all of these nodes. Let's go to supports, double click here so it will identify the nodes that are selected, and let's click on apply. Now let's define a point load to apply it in the center of gravity. The node ID will be 13 and the weight magnitude will be -5. We have created our rigid links manually and the center of gravity. Now I'm going to show you how to do it automatically by using a feature offered by SkyCiv. So in this case, I'm going to hit Ctrl A to select my structure. I'm going to duplicate it by hitting Ctrl D. The number of repetitions will be 1. The distance will be 2 meters along the x-axis. Okay, let's now delete these rigid links. Okay, so the way how we can find the center of gravity and connect it with rigid links is just by selecting the members that you want to use to find the center of gravity. Let's go to Tools. Let's click on Center of Gravity. This will automatically detect the center of gravity of the elements that I have selected. And let's click on Connect Center of Gravity node with rigid links. And let's click on Add. As you can see, we obtained the exact same result as we did it manually before. Let's now delete our first structure, the one that we created manually. And let's check the result of our last structure that we have created automatically by using the center of gravity feature. Finally, you can explore the different results of our model. For example, if you want to check the reactions, you will see that we obtained the 5 kilonewton load that we applied in the center of gravity. You can also check the displacement and the different results in your structure. Let's now check the second example. I will show you now how to splice two members. So let's go to nodes. I have prepared these nodes with their coordinates. I'm going to click on apply. I'm going to define two members. The first member that I'm going to create is from node number 1 to node number 3. And the second one will be from node number 5 to node number 7. Let's now define a section for our members. In this case, let's go to section builder. Let's select database shape. Let's click on American. See, and let's choose the first one. Let's click on submit. And as you can see, we're now using these sections for all of our members. Even though these members are very close to each other, they are not connected at this moment. So what we want to do is define a rigid link connecting this member to this member. That is the reason why I have created this intermediate node and this intermediate node in this member. So let's go to members. Let's choose node A as node number 2. Node B will be 5. And in this case, I'm gonna select type equal to rigid link. And let's click on apply. And let's repeat the same process. Now that I have spliced these two members using rigid links, let's solve our structure. We can verify that these two members are spliced together by going to the displacement option, and you will see here that these two members are working together, so we can see that the rigid links are connecting successfully these two elements. Let's go now to the third example. I will show you now how to stack two members using rigid links. I'll use the pen tool to create a beam for this example. Let's load a section from the section builder. In this case, I'm going to use an I shape. The material will be steel, and let's take into account this height because we will use it later. Let's click on submit. Now let's define some supports. I'm gonna hit Ctrl A. Let's go to supports, double click in this field, and let's click on apply. Now I'm gonna divide this member into two members. I'm gonna select it, right click, split member, split by percent of distance, sorry, and 50%. Let's click on split, and you'll see that now we have two members connected by this node. Now I'm gonna duplicate these two members, so I'm gonna select them. I'm gonna hit Ctrl D. Number of repetitions will be 1, and the distance will be the height of the section divided by 2. So in this case, it is 0.232 divided by 2 along the y-axis. Okay, let's submit. Okay, this is the result. We're going to delete these two supports. Yes, and if we check the 3D renderer, you can see the result. Let's now connect these two members using rigid links. I'll create our rigid links. Let's go to members. Node A in this case will be number 1, and node B will be number 5. Remember to change the type to rigid links, and let's click on apply. I'm gonna repeat the same process with these intermediate nodes and the end nodes. I'll create a distributed load in the top members, so I'm gonna select them. Let's go to distributed loads, double click in this field. It will identify these members that are selected in our model, and the Y magnitude, in this case I'm gonna say -10. Let's click on apply, and that's it. Now that our model is finished, we can solve our structure. We can verify that our stacked beams were done successfully by going to the 3D renderer, and here you can see the different results. If we change this scale, you can see that these two members are working now as stacked beams. Let's check now the fourth example. In this example, I'll explain how to offset members. First, I'm going to show you how to do it manually, and then I will show you how to use the offset tool we have in SkyCiv. Remember that we are going to use the same section we used in the previous example. I will create a basic structure using the pen tool. The first member will have 1.4 meters and the second one will have also 1.4 meters. I will define a support for my structure. I will double click in this field and click on apply. Let's define a point load in node number 3. In this case, the magnitude will be -5 in the y direction. Let's now duplicate our structure. In this case, I'm going to hit Ctrl A to select all of the elements, then Ctrl D to duplicate it. The number of repetitions will be 1, the distance will be 2 meters, and the direction will be in the x-axis. Let's click on Submit, and this is the result. If we check the 3D renderer, you'll see that by default all of the members are connected using the local member axis. But in this case, we want to move this beam. We want to put it right here on top of this column. So I'm going to show you how to do it manually with this left structure. In this case, we will need to separate these two members. So I'm going to create a new node. I'm going to take node number 2 as a reference. So I'm going to copy and paste these values. And in this case, if you remember, we had a section with a height of 0.2032. So if we divide it by 2, it is 0.1016. So we will add that to this coordinate in the y position, and let's click on apply. Okay, we have now that new node created, and we will redefine this node number 3. So we will use the same coordinate in the y cell. Let's click on apply, and now I'll define this member number 2, and it will be connected to the node number 7. Okay, let's check the result in 3D, and as you can see, we have now this beam on top of this column. Let's now connect our two members using rigid links. And you'll see that we have created our rigid link. Let's see how we can use the offsets. In this case, we just need to select the member that we want to offset. If we go to the advanced settings, you'll find these two options. And in this case, you can specify the distance that you want to use to move your member. In this case, we are not going to use distance, but we're going to use these top, bottom, left, right, center options that SkyCiv offers. And if we check the results, you'll find that the top of the column will be connected to the bottom of this section. Behind the scenes, we are using invisible rigid links to connect this node number 5 and the local member axis. So if you check more in the documentation, you'll find a better explanation of how the offset works. Let's now define some point loads in the horizontal direction. Okay, and let's now compare the results. If we check the moments, we should obtain the same results. Okay, we can check here a difference. The reason is, as you can see, we're using offsets in this member, but as you can see here, we define node number 3 on the same local member axis. So we will need to move this node to this position and connect it with rigid links. Now that I have created this new node and created this rigid link connecting node number 8 and node number 3, we can compare again the results. And you'll find that the moments are equal into these two examples. So as I mentioned, you can do this work manually, but instead you can just use the offsets. Thanks for watching. Remember that if you have any questions, the SkyCiv team is always here to help. Thank you.